if my polynomial, so same zeros as degree polynomials. That means that if I have an x to the power of 6 polynomial, there are 6 zeros. And those 6 zeros will form 6 linear factors. What do I mean by a linear factor? I mean something like x minus 3. That's a linear factor, and there'll be 6 of those. Yeah? That was the main thing. So the 0 would be x equal to 3 or whatever. Now, this would now includes complex numbers.
The conjugate.
So that was the other main takeaway. That if...
Conjugate has pairs.
Yes, if we have a complex 0 or root, its conjugate... oh, I'm spelling it wrong.
I just wrote a plus bi is 0.
A total blank of how to spell conjugate. Conjugate is also a 0. So a plus bi and a minus bi, shouldn't like that, are zeros. So the opposite. So the two main takeaways of the fundamental theorem of algebra: the number of solutions, or number of zeros, and the fact that a complex one will occur in pairs. Why does it occur in pairs? Yes, because when we square it, we form a negative number. Yep.
There are the two values.
Yeah, and it comes from what? Like if you think of quadratics, where does it come from in the quadratic? Why does it have? Yes, it comes from
X and the y.
the x and the y. Where does I come from? What is I? What is I? I is the square root of negative 1. So it comes from when we get a square root. So when you're like using the quadratic formula, you end up with a square root, and it's always plus minus, because it can be plus minus. So it occurs both the plus and the minus case when we square root something. The plus minus, because when we square it again, it equals only one answer. Okay. The other thing as well that we need to be pretty good on are the sum and product of roots. We'll just look at that again. The sum of roots. So the sum of roots are when we add up all the roots, so all the zeros, we get a number. And that's directly related to so adding the roots, if you're not sure what sum means, is directly related to what the polynomial will look like. A certain coefficient, so numbers in front of the x of the polynomial. So we have the sum of the roots and the product of the roots when we multiply all the roots. So multiply roots and add roots. What were those two formulas again? Can you remember?
So a minus 1 over a r. A.
So the sum of the roots is dealing with the first and second coefficients, yeah?
Negative second over.
Yeah, so you can write negative second over the first one, if you want to talk about. Yeah, it's not really the most technical way of writing. We had it with a minus n, yes, a to the n minus 1 and a to the n. But that's fine. The second coefficient over the it does work, yeah. I'll leave it like that because it might be an easier one for you to remember. The second coefficient divided by the first. The product of the roots was the constant over. So over the first, wasn't it? And we.
But if the degree is odd, then it's times by negative.
Okay, yeah. If the degree is odd.
If the degree is what?
If the degree is odd, so if it's a x to the power of 5, we know that the product of roots is going to be multiplied by minus 1. If it's x to the power of 4, we know it's multiplied by plus 1. It's just so the n here refers to the degree of the polynomial. If you're not sure what that n
We can just remember as constant.
is.
No, because that's always negative. No,
Okay.
if the degree is positive, then it's going to be positive.
Why did you remember earlier as negative c over a?
No, it's c over a because the degree is 2.
Oh, I understand. Yeah, quadratic.
Because you
With
put
the quadratic, it's
you put in the degree in for n, and then if it's even, then it's
Okay, so this is where we were at yesterday. We looked at those. We also did one question, I think. The first one here. Let's do the second question, and then I'll let you go and start your homework. Okay, so 1, 0 of this is purely imaginary. So we've got this polynomial, ax cubed plus a plus 1x squared. So it's more of these polynomials looking very like what we had for homework the other day. So one of them is purely imaginary. What does that look like? What does a pure imaginary number look like? No, it doesn't look like. Yeah, so yeah, just the BI. So remember, this is what a complex number looks like. An imaginary number is just we won't have any real part to it at all. Pure imaginary will just be BI. So we can say BI is a 0. We still don't know what B is, but we know it's a 0. Find A and all the zeros. No, sorry, I'm reading the other one. Oh, it's the same. Find A and all the zeros of the polynomial. So if that's a 0, what also is a 0?
Negative BI.
Yes. Negative BI is a 0. So how many more do we have to find? 1. And what do we know about that 1? It's a real number, pure real number. Okay, how are we going to find it?
BI times negative BI divided by that. That thing divided by that.
Okay, so you're using the product of the roots or the sum of the roots? Is that what you're thinking first?
Yeah.
Okay, so we only have 2 of the roots. So we need a third one. You could call it another variable if you want, yeah.
If 1, 0 is purely imaginary, is the other one also?
Yeah, so we have these 2. That's 1. That's 1, 0. That's 2. The third one, we don't know, but it's going to be real. We know that.
Wait, does the second one have to be purely imaginary, or can it also be a like minus BI?
It has to be the conjugate of this one.
Oh, okay.
So it also would be 0 plus BI, so 0 minus BI.
But how do we know? Oh, because it's not.
Okay, I'm open to suggestions. What road do we want to go down here? Or you can try it and I'll do one of the roads. If you want to try it faster than me, you can.
Isn't long division more like precise?
You could do long division here. What do we divide by? You remember, you can turn these into linears, is what you're thinking probably. So we can turn them into their linear buddies. X plus BI and X minus BI. Now they're the other way around to this. So this is the minus 1. This is the... Okay, and then we can form a quadratic out of this. I think the middle term is going to cancel, isn't it?
Yeah.
Which is going to be useful. X squared, and then what's the last term?
Minus B. Plus B. Yeah, it's negative B times negative 1.
Plus b squared.
Thank you, plus b squared, yes. So we square that out, and that's, okay. And we know that that times something is equal to this, yeah?
Oh, then just,
Well, all right, I've written it this way. Let's start to do it this way. You can long divide here if you prefer to divide. I'm going to use the product way. I'm just going to multiply. So we did the division way last time. Maybe it wasn't the best way. Maybe AX.
short equation. Oh, no.
Oh, that came from that. Yeah, that times that. So, but what do we put here? We know it's linear. I think AX is a good place to start here, because that times that will have to equal that.
Oh, can't we just do b squared times something equals 15?
Yeah, so what do I write that there as?
15. I don't know.
So what do I put? B squared times something. B squared times something is equal to 15. If I just want to write, yeah,
15 over
B
B
squared. Yeah, 15 over. How do I do that? Well, I just divide over here, and then I have what the box will be. Yeah.
Is this you doing this long division thing, but not love?
Yeah.
Okay.
So you could have just divided in.
Okay.
You'll end up with probably this. Well, I hope. Let's put a plus there, presuming. I think it's going to be plus. There's a lot of pluses going on.
You always put a plus, right? Because when you do minus and that's 0.
Yeah, well, we know it's going to be plus because it adds, and that's positive. So, okay. Now what?
Now you just multiply it out.
Now I'll multiply this side out, and I know that equals that's okay. That's definitely. Well, there's A's and B's, so we're going. This one's about as multiplied out as you're going to get. But you can multiply this, but I don't think it's well, let's just see what this looks like when we multiply it. We know it's going to be ax cubed. That's this times this is plus 15 over b squared x squared. Okay, that's those two done. These are done ab squared x. And this times this, we already know is 15. So that works out for us. And that equals all on this side. I'll rewrite it just so it's a nice comparison we can check. So you're thinking about what equals what and forming equations so we can solve them. We want two equations because we've got two variables. We find a and all the zeros. Okay, we've got to find a and b. So we form our equations. Yeah. We got an x squared equation. That will have to equal a plus 1. So in x squareds, 15, I'm looking at the x squared coefficients, the number in front of x squared here, that will have to equal this. That's 1. And we look at the x coefficient over here. ab squared has to equal 10. Okay, now we got simultaneous equations. Do we have the ability to solve these?
But it's just b squared to the...
Is that not a guess?
No, it's an exact. Yeah.
b squared is 15, right? Wait, what?
Or just b squared is 10 over 8.
Probably b squared is 10 over a is a nice place to start, yeah? Because that will mean I'm not dealing with squareds as much in this one. I might actually end up with a square, but not. 15 over 10 over a is equal to a plus 1. Can we deal with that? How do we deal with that? Maybe you finish it. I'll finish it slower over here. You try and finish it, get an answer for a and b. See, do we get the same one? Picking up your pen. Get rid of this. I'll finish it up here. I'll just rewrite it first, and you're doing it. So we're at 15 divided by 10 over a is equal to a plus 1. We're at trying to solve this.
Can't you just make it quadratic?
You could. What do we? So you just multiply it by a. I actually don't think it's going to make a quadratic.
Well, a over 10.
Yeah, 15a over 10 is one way to do it. Because the a's won't end up squaring, I don't think. It's going to be divided by a. You're not...
Well, you can just do times 10 over 8, right?
No, I mean times.
Oh, yeah.
Or just
So-
multiply by...
So I think either way you're going to get 15a is equal to 10 plus 10a plus 10, are you?
Yeah, and 5 8.
What do they do? You can keep change flip here with just this side. So 15 divided by 10 over a, 15 over 1, is 15 over 1 multiplied by a over 10. That's an a, not a 9. So 15a over 10 is this side, and then you multiply over by the 10. So we're at this stage, we get 5a is equal to 10, a is equal to 2. That looks nice. If a is 2, what's b? Plus or minus root 5. And then we have the zeros. How do I get plus or minus root 5? Well, a is 2 here, so b squared is 5. So b squared is equal to 10 over a. B squared, we just found a to be 5, so it's 10. B is equal to plus or minus root 5. So there's the two answers for B we wanted. All right, time for you guys to start your homework. Let's see. Hi. Yeah. So that's it. Not too much. I don't think it's too much.
What's too much? What's a lot?
What's a lot?
These are like long questions.
Okay, look at the very first question. Find the sum and product of the roots of these.
So how many questions do we have to do?
First question, just do 2 parts, fine.
And then the rest we have to do.
Rest, just do them all, yeah, because there's no like repeated question like that.